Good morning, everyone. My name is Eric Durano. I'm a professor of information science at University of Arkansas at Little Rock, and I'm serving as track co-producer alongside Samantha Maxim and Prashant Sutekal for Virtual Track G, Global Issues in Data Analytics and Management. It's my pleasure to introduce the next session, Effective Data Governance and Agility through Zero Trust for Data. In this session, you'll hear about how to achieve a high level of confidence when it comes to the safe and authorized use of an organization's data. To make this happen and to get rid of data silos, zero trust architecture principles are applied. Before I hand things over to our speaker, a few housekeeping items. So the session is being recorded, and these video recordings will be uploaded to the CDOIQ YouTube channel about 3 months after the symposium. Any presentations will be included in the symposium proceedings. And finally, there's a question and answers section at the end of this talk. If you want to submit any question, please use the Whova's app Q&A tab. With that, I'll turn things over to this session's speaker, Aaron Cordova from Coverse, an SAIC company. Aaron, over to you.
Well, thanks. I'm going to go ahead and get started with my slides here, and I'll try to watch the app for questions. Make sure I try to answer those.
I can go through the app at the end, and we can go over the questions.
Okay, appreciate that. So, hi, I'm Aaron Cordova. I'm the CTO of Coverse, an SAIC company, and I'm going to be talking about effective data governance and agility, specifically, how to achieve agile data governance, which is, maybe a new topic in terms of data governance. So I'll go ahead and get started. So what do I mean when I say effective governance? Really, that's what I mean is the ability to achieve some amount of control and understanding of your data, knowing how much data you have, what data it is, what is the structure of the data, how accurate is it, is it out of date, or is it up to date? And then, where does your data come from? What's the provenance? What's the lineage? How is the data being access controlled? Who can see the data and how can they access the data? And what has been done with the data in terms of auditing everything that folks are doing with that data. And then really the hope is that folks can get a good understanding of how their data is being used, and really what is the value of that data to the organization. So these are, this is not a comprehensive list, but this is an attempt to kind of describe what are, we trying to achieve. And what I mean by agile governance is, maybe not included in the typical list of things that are required for effective data governance, but are nonetheless important to an organization. And so what I mean by agility is, can you bring new data sets online quickly? Like, how long does it take from the time new data is available until it's effectively, until governance has been effectively applied? And how quickly can people start to make use of that data? That's something I don't think is typically considered necessarily in, requiring that the data is effectively governed. Is the data available for different uses, both analytics and access by direct users? So, just because the data is well understood and it's under control doesn't necessarily mean that everyone who wants to use that data is able to the way they want to. So some folks want to access data in bulk, like process an entire data set. And if the data size is non-trivial, they may be prohibited from doing that unless measures have been taken to make that data available in bulk. At the same time, a lot of data sets are available perhaps for analytics, but not necessarily easy to explore by individuals. And so, what has to be done to the data to make it available just for discovery, for verification purposes, or just for search? So that's kind of an important question. And then, how quickly can that data not only be just brought online, but if there's changes to the data or new data that's going to be added, how quickly can that be done? In some cases, people who are using data need to have it with have those updates with extremely low latency, like in low numbers of seconds or even less than a second, if the data that they need to use is effectively represents things that are happening in the real world in real time. So that becomes an interesting question in terms of, how do we apply data governance without imposing drag on the data and latency? Kind of back to what I was saying about, can folks access the data the way they want to? An important set of use cases is making data available to basically interactive applications or live decision making. And this kind of goes hand in hand with getting data updates with low latency. Is the data accessible in a way that applications that allow users to interact with the data can do so? And is that data supporting like decision making that's happening in real time? And another question is just, how many people can make decisions based on that data? Does it support a large number of concurrent users accessing the system all at the same time? And then, more relevant to zero trust and security is how quickly can changes in access based on changes in the organization, how quickly can those be made? So it might be the case that I've never had a need to access a particular data set, but because of a change in my role or because of a change in mission requirements, all of a sudden it might be very important for me to get access to a particular data set. And the question is, how long does it take for that to happen? So once I am authorized on an organizational level, how quickly is that authorization reflected in the access control rules that govern the data? And then a big one that I think is important to achieving agility with data governance is, can the data be used in ways that were not anticipated when the data was first made available? So, I might identify a data set as being useful for a particular use case, but it may be that all of a sudden the data needs to be used in a different way. And the question is, how well does the data governance process support that? Is it stored in such a way that it's easy to use for particular use cases, but impossible or difficult to use for other use cases? And by that, I kind of mean from a technical standpoint, like if I'm able to do business reporting using a particular data set, that may be great, but what if I need to make it available, for interactive search? Can I do that quickly? And then kind of related to that is, how am I able to combine data? And this one is really interesting because this highlights a difference between the way data is governed from two different architecture perspectives. So I think in the industry, we've been talking a lot about data lakes, data lake houses, data fabrics, and data meshes. And all of those are kind of different approaches to allowing folks to, govern their data and access it and make use of it. But there are major differences between the capabilities of those architectures when it comes to doing things like combining two data sets. So for example, in a data mesh, data might be kind of distributed around the enterprise, and I might be able to access the data in certain ways. But if I need to combine that data, like, basically physically, if I need to do a join of two data sets, if those are kind of separated and communicated over the network, can the network support bringing all that data together on demand? And then there's an architecture like a lake house or a data lake where the data is maybe physically co-located. The ability to join two data sets is different. It's arguably easier if the data is already physically co-located and there's a high degree of bandwidth available to combine that data. And the key here is how long do I have to make sure that I can do what I need to with the data. It might be, again, that it was fine to have the data, two data sets in separate places for a long time, but all of a sudden there's a new requirement that I need to be able to combine those data sets. And, this all kind of falls under the overarching goal of making sure that data is viewed and available as an asset to the organization. Not something that has to be like necessarily, a burden in terms of, I need to host this data somewhere. I just want to check the boxes and make sure that I'm not running afoul of any security policies or compliance or regulations. But rather is the data kind of available to me in terms of helping me solve problems when it comes to answering questions about the organization. In that aspect, it's more like an asset rather than something I need to worry about. So all of this falls under this concept of agile data governance. I guess what I'm arguing here is that if folks strive for agile data governance, then it's much easier to present data as an asset to the organization because the data is responsive to the changing needs of the organization. So as decisions are made and as new changes happen in the marketplace and the enterprise wants to respond to those, how well is my data supporting the organization in making those changes? Or is it a major headache? And so what I'm going to talk about is how those subtle differences, like that I could sort of touched on with respect to data architectures, can make a big difference in terms of agile data governance and in terms of how effectively data can be applied to new changes and be responsive. So I'm going to touch on a couple ways that that might be helping and a couple of approaches that might be hurting the effort to achieve this kind of agile data governance. So, I kind of talked about how if data is physically separated into different stores, that can present an issue in terms of agility, purely because of the physics of the problem. So if the data is, again, non-trivial in size, and it's siloed into different stores, I'm physically limited in terms of what I can do with that data. If I try to combine two entire data sets that are physically separated, I'm constrained by the capabilities of the network. I'm constrained by, if they're geographically separated, there might be, the speed of light might affect my ability to do that in terms of how quickly I can bring that data together. Another big issue that I'll get into in pretty good detail is the data is often over or under protected because of the coarse granularity of access controls. And that can have a big effect on agility because, I might actually be allowed to see certain portions of a data set, but because I can't see all of it, and because the access controls aren't fine-grained enough, I might not be able to use that data set at all, even though there's parts of it that I should be able to use. And that can cause a lot of problems, because if I really need to access that portion of the data that I need, and someone has to go and extract that information for me, that's going to put a huge amount of drag on my ability to answer questions quickly. And then, that can be true of the governance process itself in terms of how, quickly data can be put to use. because we want data to be well governed, we want it to be well understood. And so the real question is just how do we do that? How do we bring data up to speed and so it meets the requirements of the governance process without creating a lot of latency and creating a lot of friction in the process? And I'm arguing here that a lot of technologies can make that process easier or more difficult, basically depending on how well they are designed to support the data governance process. So data stores that are designed with data governance in mind can make a big difference in terms of how agile users can be when it comes to using data. But there's a lot of technologies that are designed for kind of outside of the data governance process, and now we're trying to apply data governance to those systems, and we're just not getting a lot of support from those technologies. So I'll talk about what the specifics of those are. We've, had a big kind of shift in terms of how data has been stored and managed recently. And we've seen a wide range of approaches to this. And one of the big ones is a data lake, which is, designed to make it easy to kind of stage data in a way, bring data together and try and centralize it in some sense. So that may be more of a virtual sense, but it may be actually in a very literal sense where you're bringing data together in the same data store. And, the reasons for doing that is because they can simplify the governance process, and it can certainly make it easier for folks who are looking for data to have one place to go to find it. The only kind of issue that we've seen with folks using data lakes is they tend to be lacking in critical capabilities. So because they tend to try to address kind of the lowest common denominator in terms of requirements for being able to put data in, they also tend to not offer very, very much in terms of capability. So a data lake might allow me to store structured and unstructured data, but even though I put structured data in a data lake, it might not give me any ability to take advantage of the structure of that data. So for example, I can put a bunch of CSV files, comma separated values files, which are a type of structured data, into a data lake. And the data lake is only typically going to let me access entire files at once. When it comes to accessing individual records within those CSV files, I may not have as much capability. And that impacts things like how access control is applied. It's often applied at the file level or the directory level, as opposed to the individual record level. At the same time, data lakes might not give me a lot of capability when it comes to exploring the data. So being able to search across the content within the data lake is typically something that's difficult to do. So while it helps in a way because it addresses some problems in terms of centralizing data, making it easier to, say, combine data sets, there's usually a lot left to be desired in terms of how well I can interact with the data that's in a data lake. Similarly, a lot of folks when they go to apply data governance to across a bunch of different data sets within the organization, we've seen that some folks will say, you know what, it would be nice to be able to maybe combine this data into a centralized location and apply access control that way, but that might be a little more difficult than we're willing to do right now. So let's add a security layer that goes over all these different data sets and tries to apply a uniform approach to securing that data. And that is certainly helpful. Where that solution might fall short is that with data in different types of systems, even though I have a uniform security layer in front of it, ultimately the enforcement of the policies that I want to impose on these different data stores can be enforced differently based on the capabilities of those data stores. So, a file system is going to give you different access controls than, say, a relational database. And that might be different than maybe a streaming source. So again, that's kind of a partial solution, but you can run into important differences in terms of how access control is actually applied to that data. And then finally, it's all of the things that data governance is trying to achieve in terms of giving folks better quality data and better understanding of data. The way that folks try to bring data sets up to that standard can vary widely. And a very typical thing that happens in trying to make data meet those requirements is that it might be the case that an organization says, well, I really don't want anybody to be working with data until it has met these requirements, which is makes a lot of sense. But the question remains like, well, what can I do with data before it has met those requirements? What do we do with data that is ill understood, that data is new, or data that is changing? Is there any way that we can, one, make it easier and faster to bring data up to speed and bring it within the data governance regime? And what kind of tools do we have to work with the data before it's met those requirements to get it up to those standards? And that can slow things down. In the worst case, it can make certain data sets unavailable for a long time because it doesn't meet the requirements. And we're going to argue here today that there are things that you can do to data sets that are like that, that make it easier to get them up to speed and still make them useful even before they're fully understood. So those are kind of some challenges that we've seen that in terms of achieving data governance, and what we've seen to be effective solutions to some of those. And these are basically technology independent. So we're a technology company, and we provide a data platform that supports the data governance process in a lot of these ways. But these are things that you can apply, kind of regardless of technology, or you can use when looking for, comparing technologies to each other. And so I'll just go through these. One of them is a physical location, but physical co-location and logical isolation. And so, back to the data lake idea, if I can centralize in some way the way I approach my data, that's good. That simplifies things and makes it easier for me to govern the data. And we would argue that physically co-locating your data can give you a lot more agility in terms of what you can do with that data with a short amount of notice. But you can also, it's also important to logically isolate that data, not just for security reasons, but just for managing data. And so technologies that allow you to physically co-locate data so that if and when data does need to be combined and aggregated, that's possible and that's fast. But it's also important to be able to have as much isolation as required by the data governance process. So for example, if I have access to one data set, that might disqualify me from accessing another data set because those two should never be combined. So you need the ability to apply logical isolation when the data is brought together. And some technologies might make that logical isolation harder because the data has been physically co-located, maybe because the data store hasn't been designed that way. But there are technologies that allow you to do that. The second kind of big thing that we see is just kind of flipping the approach of how we manage data quality on its head, and this concept that I'm calling data problem forgiveness. So, there's the gold standard that, is typical in what we would like to see in, say, a data warehouse. There's a huge amount of value in saying that we're not going to put any data in a data warehouse until it meets the gold standard of quality and provenance and being well understood and changes not happening when we don't anticipate them happening. That makes everyone's life easier who uses the warehouse, because they know that it's going to be consistent, it's going to be accurate, and any changes are going to be advertised well in advance. However, when it comes to, what do I do with data that doesn't yet meet that standard, oftentimes it's kind of treated as a second-class citizen. And it's like, well, we're certainly not going to put it in the warehouse, but then where do we put it, and what do we do with it? And if the answer is, well, I hope that the data engineers that we have on hand are able to process that data, writing scripts or whatever, processing it in a file system before it's put into the warehouse, that can create a lot of drag and keep data sets offline for a long time. So what we're arguing is it should be possible to have a system that supports both high quality gold standard data, but also low quality, ill understood data that needs a lot of attention before it meets that gold standard. And we should be able to use as many tools as we can in terms of getting that data up to that gold standard. The next kind of technology I would argue is important for agile data governance is ubiquitous indexing. So if data is just kind of sitting in a big a file system somewhere, I'm really limited in terms of my ability to explore that. And if I have the ability to index that data and understand it, even if it's messy, and especially if it's messy, because I might need to do some exploratory analysis of that data to figure out what the data quality problems even are. And if I'm able to search through that data and look for things that are supposed to be there, also look for things that are not supposed to be in a particular data set and find out if they are or not, indexing can go a long ways towards making data better understood and allowing it to be explored so that we can make an assessment about how close is this data to meeting that gold standard, or do we have a lot of work to do before we do that. Another kind of solution to this problem is, as I'm moving data from a low quality state of being towards that gold standard, what does that process look like? And as people extract data or process data and create new results, how do I manage those results? And how do I advertise the fact that I've taken these, one or two data sets and combine them to create a third data set, and there's a relationship there. And I would argue that, agile governance would include the ability to support that process, not just for cleaning up data, but also if I'm going to be creating analytical results that are based on certain data sets, I need to understand that relationship. And I need to be able to, the same way I want to treat messy, ill-understood data as a first-class citizen, I also want to treat derivative data and analytical result sets as first-class citizens. And I want to have all the access control and the discoverability of that data to be a part of what I'm offering to data consumers. And then finally, something we call, zero trust security. There's a lot of talk right now about zero trust architectures. We see that as a way of really solving the security issues that can otherwise cause a lot of problems for agile data governance, both in terms of, the data needs to be very well controlled in order for me to even bring it online, and especially to co-locate two data sets. So if I'm going to co-locate two data sets in a system, I have to be very confident that that doesn't imply that everyone who can access that data store for the purposes of reading one data set automatically gets to read any other data sets that are in that system. So any sort of a data store that is going to support co-locating data sets has to support strong access controls around that data. before data owners will ever sign off on handing the data over to that system. And specifically, we argue that fine-grained attribute-based access control is effectively the gold standard in terms of security. What that really means is just that whatever the security policy says needs to happen to protect a data set, however complex that security policy is, the data stores that we use need to meet those. And I really can't just tell a data owner, well, I can't protect your data in terms of on a row by row basis, or I can't protect your data on a column by column basis. So I'm just going to lock the whole table or lock the whole data set. Because at that point, I'm either denying people who should be able to access the data from seeing the data they're allowed to see, even if they can't see all of it, or the worst case is I'm underprotecting the data and giving folks the ability to read all of a data set, even though they only are really allowed to see a portion of it. So that's where fine-grained attribute-based access control comes in. It basically allows me to protect data to the degree that security policies require. And we'll get into kind of what that looks like in a moment. So just to touch on kind of how these effective solutions work, what we're talking about with physical co-location and logical isolation is, again, if you have sufficient security controls, then physically co-locating the data does not create any new problems. It doesn't make it any easier for someone that has access to one data set to turn around and access the next data set just because they're physically co-located, because there's strong logical isolation in place. And the biggest thing, though, that buys you is, so it preserves your ability to isolate data sets, but what it buys you is when and if it becomes time for that data to be combined. And this may be something you don't anticipate for months or years until all of a sudden you have the need to do it. If the data is physically co-located, you have zero data movement when it comes to combining that data set or those two data sets. And that is something that becomes critical when the needs in the organization change, and you have to try to answer a business critical question in time for it to be effective. So if there's some sort of IT change management request that has to happen first, that can basically make it so it's not even worth doing, because by the time we move the data to the system that allows us to combine it, the answer may not be relevant anymore. The other thing that happens is it becomes important to be able to store both unstructured and structured data and semi-structured data all in the same system. And that's because, it's not like we can guarantee that I'm only ever going to need to combine structured and structured data together. And I'm never going to have the need to combine data from, say, a bunch of documents with data from, say, our structured customer records. There's no reason that guarantee should exist. So it's important to be able to store multiple data types in a centralized data store for that reason. And then when it comes to how do I access this, again, we don't want to create new issues by physically co-locating data. We want to maintain or even improve our ability to protect the data so that as users are making access requests, we're authorizing those on a request by request basis. And just because you had access to data yesterday doesn't mean you necessarily have it today. Just because data happens to be managed in the same system doesn't mean you can access all of it. So physical co-location goes hand in hand with being able to secure the data properly. And then getting back to like data problem forgiveness, we basically are arguing that we want to be able to extend the data governance process to include, what do we do with unknown, messy data? that should be part of the governance process. So the way we treat that data should be, one, the sensitivity of that data might not be well understood either. So we need to be able to basically quarantine it, and give data owners or data workers the ability to address, and assess the sensitivity of that data. What is it? Has it changed? Does it match the structure that we've been told it should have? And one thing that we've discovered is really effective is it's possible for a technology to help us with those things. So you don't have to answer all the data structure questions that you have by having a human look at the table and write down what they see, and then say, I think we should create a database table that has the following fields, and each of the fields should have the following types. Those are things we can discover from the data itself by simply doing a pass over the data, looking at all the various data types that appear. And, if it so happens that the zip code field is mostly zip codes, but we also find some strings, some text in those fields sometimes. Well, okay, that's something that the system should be able to tell us, and should tell us how frequently that happens, where those records are, what is the text that's being put in there, and that can help us figure out, do we have a data quality issue in terms of how the data is being created, and then also it can help us understand when that problem has been solved, or allow us to apply our own solution to that problem by cleaning up the data. And that's why having messy, ill-understood data within the system that we're using to apply data governance is important, because we'll want to be able to clean it up. And, and you want to be able to use the full power of your compute resources, any data analysis tools that you might want to bring to bear on addressing data quality issues. We should be able to deliver messy data to those analytical tools with good performance and with access control. And so this actually becomes one of the most important parts of the governance process is in, figuring out what we do with this data very early on. And then we can decide if we want to clean it up, and we don't have to only clean it up in one way. So it might be that, I have a good understanding of what this data should look like, and I can, I think it's okay to drop all the rows that have text in the zip code field. And that's a decision that I'm going to make. And I should be able to do that. But if someone else comes along and says, actually, I'm really interested in those text fields because I think analysts are putting important information in there, and the zip code field happens to be the only one in the user interface that allows anyone to comment, so that's why they're doing it, and that information is something I actually want to analyze, I should be able to go into the system and extract just those records. So I should be able to go back to the original and see all the information that's there. So that prevents approaching data this way allows us to avoid information loss. It also allows us to clean up and normalize data in more than one way for more than one purpose. And then I can, take the traditional process of getting my data up to the gold standard can take over. And again, you can do it in more than one way. So there's talk of this like progression of data from bronze to silver to gold that you might see out there in the marketing, and that's a great process to be able to support. It just happens to be very specific to machine learning. So what a lot of folks are talking about when they talk about going from bronze to silver to gold is taking data and getting it ready for machine learning, and making sure that it's easy to update that and then retrain AI models. But I might have one part of the organization might be all about that, but I might have no interest in machine learning. I might want to clean up the data, bring it up to a high standard for the purposes of, say, business intelligence reporting. So I should be able to create my own, I'll call it platinum version of the data set, because it's just as cool and important as the gold data set is for AI and machine learning. And so really this is just saying that, building data forgiveness into the process is something that is critical for doing this kind of agile data governance. And then there's a lot of reuse that gets enabled here too. So if someone's cleaned up data in a way I agree with, I don't have to do it again. I can just start from that checkpoint and then process the data the way I want to from there. But I don't have to start at the beginning every time. And that's another important, that buys you a lot of agility. The fact that you don't ever have to go back to the very beginning, you know, unless no one else is doing what you're doing in terms of cleaning the data the way you want to. And you know, this kind of came up earlier when it comes to like, well, what do I do with this messy data? I have to be able to do some amount of discovery and validation of that. Having that data indexed and searchable makes it very easy for me to do that. I can very quickly find things that I think, you know, should be in the data, verify that I've got the right number of records, and I can easily discover data problems and kind of drill down on, you know, why that's happening, what fields are affected, and how might I need to address those problems. And so supporting the analytical lifecycle means that I should be able to use any tool that I'm familiar with to interact with the data. And that's why I don't want my data store to only support one method of processing the data, is because I need to use different tools at different times. So I might want to do some very manual cleaning or normalization. I might want to use rule-based controls to clean up the data. But I'm likely going to need to do that in bulk. So when I have rules for cleaning up data that I like, I want to apply those to the entire data set, maybe multiple data sets. So the system needs to support both exploratory data analysis and also bulk analytics in order for me to do that. And then I've got SQL here and AI just as two examples of very different ways that I might want to also process the data. And being able to extract data and create new data sets and publish those into the data store as newly available data sets is really important, because every data set that's managed by the system is going to be highly access controlled, is going to be very capable in terms of my ability to read out data in bulk or explore it via searching the indexes. And this basically gives all my data, no matter, you know, what I'm using it for or how well it's understood, it gives my data the same properties and the same capabilities, so that whatever I need to do with my data, I'm well supported in doing that. And then finally, it's often the case that the output of one of these processes might be something that's very valuable for decision making on a moment-to-moment basis by a large number of decision makers in the organization. So I also want my data to be highly available, accessible through an API, accessible through a search interface, or something I can embed in an existing process, so that as data is being derived to help make decisions, I'm getting that information into the decision-making process at the point of decision-making. So we need to be able to do any and all of these things at any time. And then zero trust, to kind of drill down on that, really what that means is we want to eliminate what are called implicit trust zones. So an example of an implicit trust zone is like, I log into a database and now I'm implicitly trusted to read all the tables in that database. Most databases don't do that. Most databases will constrict your access on a table by table basis. But then the question is there still any implicit trust zones remaining, or can I shrink those into specifically controlling exactly what I'm allowed to see? So even though I can control data access on a table by table basis, is that too coarse grained? So if I can access some rows of a table, does that always mean I can access all the rows? Or some columns, does that imply I can access all the columns? If the answer is no, then you've eliminated all those implicit trust zones. The other thing you want to eliminate is trust over time. So just because I could access something yesterday doesn't imply that I can access it today. I need to be able to authorize access control every time a user makes a request. And again, this is the key to co-locating data without causing any security problems. It makes it really easy to audit everything everyone's doing with the data. And what's really nice is then I can, if I use this data store, zero trust architecture as the way that applications get data, then those applications don't have to be very smart in terms of fine-grained access control. They can issue requests on behalf of users that may have very different need to know, very different accesses, and the data layer is going to handle filtering out anything that they're not allowed to see. So you can use legacy applications, off-the-shelf web applications, BI tools, and they will all inherit that security because the data layer is where it's being enforced. I kind of talked about what implicit trust zones look like, and what we mean when we shrink those implicit trust zones means that data is protected at the level where it varies in terms of sensitivity. So if data varies from row to row in terms of sensitivity, then data is protected at the row level. If data varies, from application to application in terms of sensitivity, then that's the level that we control the access of those applications. And I mentioned something called attribute-based access control. And the question is like, how is that different? And what's very common in data stores is role-based access control, where if I have a particular role and that role has been granted access, say to a table, then that's all that's needed to decide whether or not I can access that table. What attribute-based access control does is it allows users to be given individual attributes. And the set of attributes that I have may differ slightly from the set that my coworker has, and that's okay. And so you can actually have a large number of sets of attributes that vary widely across your organization. And attributes are things like, can I access confidential data? Have I taken training so that I can handle sensitive data like clinical trials data? What is my nationality? Am I an employee? Am I a contractor? Where am I currently sitting? Am I sitting in the office or am I working from home? All these can become attributes that are used to evaluate access control decisions. And then the second part of this, so assigning attributes to users is step one. Step two is labeling individual data elements with whatever attributes are required to access that. So, and these, unlike role-based access control, is not a simple yes, no. It's basically a rule set. So for example, if I want to read row 001, I need the ability to access highly sensitive data, and I need to be either a US citizen or a UK citizen. So that rule is actually a security policy that lives with the data and can be applied to very small data elements. It could be applied to a document, or it could be applied to a paragraph within a document. And this is what we see with like classified data is often has human readable labels that can be translated into these digital labels. And then the data layer, if it supports attribute-based access control, is the policy decision point and also the policy enforcement point. So it's going to decide what you can see and not see based on your attributes. And then it's also going to filter out the stuff you can't see. And that's what step 3 is evaluating on every request, what are your attributes right now and what do those allow you to see? So even if I've done a query on a bunch of documents and there's 1,000 documents that match, my attributes may only allow me to see 700 of those, and the data layer is gonna enforce that. And so, what can be an attribute? It really depends on your organization, and different organizations have different needs. Like in the DoD, it's like clearance level, nationality. In healthcare, it's what are your qualifications? What are the specific training you have? What projects are you working on, and what do you need access to, and not just to do your daily job? And so these are things that don't have to be decided beforehand. And in fact, if new attributes need to be assigned to users, the system should support new attributes being introduced to the system without having to make a lot of changes. And the way this works in practice is you no longer have to authorize folks for entire tables or documents. You can authorize them for specific elements within those tables or specific paragraphs within those documents. This can also be applied to systems. So a big problem that we see is that administrators have maybe like full reign. If I can log SSH into a machine, that gives me access to all the data on that machine. So that should not be the case. You know, the data, I should be able to log into a machine and maintain it from an administrative point of view without necessarily gaining access to all the data on that machine. And then in the broader enterprise, the way this looks is with a zero trust architecture is you've got different applications, different types of data. Ideally, you have a single data layer that supports this fine-grained security control, and users are logging in. The system, the data layer is fetching their credentials on every access request and authorizing them to do what they're trying to do. And really what this does is, in the case of overprotection, is it eliminates the case where there's data that I need that is relevant for my job, but because I can't see everything, you know, I'm not allowed to see it. So in this scenario, if there is even just, you know, one column out of a data set that I'm allowed to read, I can do that. And if my access control changes from now till, you know, in the morning, I didn't have any need to know a particular access a particular data set, but by the afternoon, I was put on a new project and I need to get on it right away. The fact that we're checking access control on every request makes that possible. So this can have huge benefits in terms of like consolidating data silos. A lot of people are separating networks for security reasons. You can eliminate that. Better protect data. You can better understand who's using your data and for what reasons. And, you know, analysts can go to one place and get access to everything that they need. It also makes it easier to answer that question of like, have we done a good job of, are our security policies properly applied? It's easy to go to the system and say, well, yep, here are all the rules. Here's the security policies as they've been applied to data. I can easily determine what group of users are able to see a particular piece of data because it's all being controlled by that single process. Another kind of interesting thing in this is a question that was asked earlier about ensuring the integrity of the data. So some of the way these data systems are built is such that the data is immutable. So that means that if you're bringing data into the system, it's going to be stored in the system the way it existed when it was ingested. And then if users need to go make changes to that, we're gonna ingest those changes without destroying the original. So, and then at read time, you can decide whether or not I want to see past versions of the data or I want to only see the latest version. But this buys you a lot in terms of assurance, knowing that even if users have made changes to data, that the older versions are still there and we can see who made a change to a particular piece of data and why. You know, was it through an application or was it just new data that was ingested from a data source? So these are the types of things that can make it easier to accredit a system and get data approved. And a big part of this too is giving data owners and data stewards enough control over their data so that they're confident that they can, you know, make data available without undermining their stewardship and under protecting the data that is their responsibility to protect. So even though a lot of these security requirements might seem like pretty ambitious, we found that security is really an enabler for giving folks enough confidence to make data available.
Aaron, I have about 6 more minutes.
Okay, thanks. So, how to get started with this is just, consider what security rules exist in your organization. Usually they're written in natural language. And then, the question is, how do I convert that to like a digital policy? There's kind of 2 steps. One is just identify the different attributes that differentiate your users from in terms of access. And then the second question is, okay, how do I label data in terms of those attributes so that it's protected the way I want. And then if you have different organizations have different things they care about when it comes to security. So some organizations might care a lot about where a user is when they're accessing data. Other organizations might not. So and that's okay. It's okay for there to be like a lot of different specific needs when it comes to securing your data. So that's everything that I wanted to talk about in terms of achieving agile data governance. I'm happy to jump into questions now if we have specifics. I'll check the app too.
So there's still that one question that was from the beginning, and I think you may have already addressed it. How do you ensure that contents of the data are not corrupt while in transit?
Yeah, so I mean, one way to manage that is as data flows are coming into the system, that's where the ability to discover and compare information in terms of what's been ingested versus what's in the source system, that becomes really important. And I would argue that, being able to use the system to verify that is important. The other half of that story is, does the system enforce that itself? And that's where I was talking about the way you treat changes. If you treat changes to the data as a history, like a change log, that can give you a lot of confidence in terms of ensuring that data hasn't changed. Or if someone wanted to change the data, when did that happen? Who did it? And why did they do it? Those are big things. When it comes to delivering data to end user applications, this is another reason why the analytical lifecycle is important. So if data that's leaving the system is processed and then published back to the system, then I'm not worried about having all these different copies of the data in the wild, say, which can create problems in terms of consistency, but also in terms of control and governance. If data leaves the system and is cached somewhere, the auditing rules that I have at the data layer are no longer apply. So from an auditing point of view, we want the data to be managed by a kind of continuous data layer so that there is no ability for folks to, create their own copies that aren't subject to the same auditing rules and compliance rules as the data layer is. So that's why it's so important for the data layer to support all the tools that users need. So they're not tempted to try to extract the data and manage it in a system that is completely ungoverned. But when it comes to like specific integrity checks, things like that, those are all things you can apply. Checksums are a way to do it. Cryptographic signing is another way that we've seen that folks do that, so that if I do extract a piece of data, I can verify that it hasn't been modified since the time that the cryptographic checksum was created. So you have the ability to use all those traditional solutions to that problem. But I do want to point out that the way the data layer is set up and how users extract and publish data back to that system can have a big impact in terms of maintaining the integrity of your data.
And there's two more questions. I'll go in order in which they were asked. What is the best way to clean data?
To clean data?
Yes.
Yeah, so my answer is the same answer to, what is the best, someone was asking a Marine at one point what the best firearm is. And the Marine answered, it's the firearm that you're most familiar with. So I would say that the best way to clean data is to use the tools that you're most familiar with. We've had a lot of success though with low code, no code tools. There's a tool that SAIC makes available called Tenjin that gives you the ability to create pipelines where you can clean data up and have basically a succession of versions of your data set as they get cleaner and cleaner. So if you want to modify any of the rules along the way, it makes it easy. Tools like that are really impactful. Tools like CDOIQ, but there's also commercial companies out there that are using things like AI and ML to clean up data. I think Tamer is one of them that's maybe based here in Boston. So our answer in terms of just advocating for supporting the data governance process from the data perspective is the widest ranges of you want to be able to use the widest range of tools possible, because the right tool for data cleaning is probably, for your organization might be different than another. So you need to be able to use the tool that you find the most effective.
And unfortunately, we are out of time. But there is a question you may want to answer, reply on the Whova app, and I'll ask everyone kind of look over there. Thank you so much, everyone. Thank you, Aaron, for a very interesting talk.
Yeah, thanks everyone. I will answer that question in the Whova app, and I'll also be available at the SAIC booth if folks want to just come and chat. So thanks everyone.